7.3, power to power, another version of the product rule. This says that to raise a power to a power, you need to multiply the exponents. So, for example, in the arithmetic, 2 to the third to the second, we would leave our base the same. Oops, let's grab a pencil. We would leave our base the same, and we would multiply our exponents. So 2 times 3 is 6. Now, the reason why the product rule with power to power works the way that it does is because when you take 2 to the third power, 2 to the third power is 2 times 2 times 2, and you're taking that and you're squaring it, so you're multiplying it by itself. So 2 times 2 times 2. So all together we have 2 to the 6th power, because we have 6 2's that we're multiplying together. It works the same way with the algebraic method. It's just you leave your base the same, which is a variable in this case, and multiply your exponents. If you know what your exponents are, you can get a number. If you don't, you leave them as a variable. Let's look at example A. In example A, we're going to leave our base the same, and then 3 to the second to the 4th power, we're going to multiply those exponents. 2 times 4 is 8. Now, 3 to the 8 is a number that you can evaluate using your calculator. It's large enough that I don't expect you to have that number memorized, so you could, if you wanted, just leave it that way. In part B, you're taking x to the 3rd power all to the 5th power. So it's a power to a power, so we're going to multiply our exponents, so we get x to the 15th power. In part C, we see that we've got negative 9 squared to the 2nd power. Please be careful with your negative 9 squared. You're still going to take your power to a power, but we've got negative 9, and we want this still to be in parentheses. 2 times 2 is 4. And then negative 9 to the 4th power, that's actually the same as saying 9 to the 4th power, because if you take a negative 9 times a negative 9 times a negative 9 times a negative 9, these are a positive 81. Remember, because a negative times a negative is a positive. So we'd end up with a positive number in the end. In part D, don't let negatives throw you off. It's okay to do the same power to a power rule, leaving our base C the same, and then multiplying our negative 3 times our negative 2. And a negative times a negative is a positive. We get a positive 6. In part E, x is our base. With the power to a power, we multiply. So 2 times negative 3 is a negative 6. We do not want negative exponents to be completely simplified. So we need to remember our rule for negative exponents, that a negative exponent indicates you're going to move to the opposite side of the fraction bar. So this, written in completely simplified form, would be 1 over x to the 6th power. In part F, again, we've got a negative in our parentheses, so we're going to keep that in the parentheses. 4 times 5 is 20. Again, because this is a positive exponent, you could also write this 2 to the 20th power. As we get a little bit more complicated here, in part G, and let me kind of zoom in here, we want to make sure that we're following our order of operations. And we've learned a couple of rules. We know how to combine using our product rule, where if we multiply 2 exponents with the same base, we add the exponents. And we know our power rule from today, that if we take a power to a power, we multiply. So we're going to leave this 9b squared by itself for just a moment and use our power to a power rule on the second part. So b to the fourth power all to the second power, we multiply our exponents. We get a b to the eighth. So we've got 9b squared, b to the eighth. And because both of these have the same base of b, when we multiply them using our product rule, we're going to add our exponents. So we get a 9b to the 10th. All right. So remember to combine those common bases. All right. And we're going to move on now to our next slide and take a look at what happens when you have more than one base inside your parentheses. All it means is that you're going to distribute to each of the pieces inside, and this could be in multiplication, it can be in division, but that power to a power rule applies to everything within your parentheses. So if you look at the arithmetic example here, we've got a 2 to the third power times a 3 to the second power, all squared. So we're going to take this, and I'm going to write it out in two ways for you. So 2 to the third power to the second power times 3 to the second power to the second power. So I've essentially distributed that exponent to both pieces. Now we use our power to a power rule. So power to a power means we multiply, so I'm going to have 2 to the sixth power times 3 to the fourth power. And then that's something that we could simplify to get a number. You do not have to write out those steps of splitting it apart, but if you're having trouble thinking about it all as one, it's easier to split it apart to look at it. So in the second example, a and b, a to the third, b to the fourth, all squared, we're going to have a to the 3 times 2, which is 6, and b to the 4 times 2, which is 8. And that would be as simplified as possible because our two exponents have different bases. All right, so we're not going to worry too much about the meaning. As we look at our problems, we're just going to work through and find our answer. Something to recall that as we're looking at our problem here, x to the third, y, all to the fourth power, because y doesn't have an exponent written, there's an exponent of 1. So as we do our power to a power rule, we're going to take x to the third power to the fourth power. Power to a power we multiply, so we get an x to the 12th. And then we've got our y to the first to the fourth power. So we'll have y to the 1 times 4, which is 4. X and y are different bases, and so that is as simplified as we're able to get. Now, with our second example, we've got a 2x to the fourth, and the numbers and the x's are going to be dealt with differently. So, or separately, I should say. So this is a 2 to the first power. So we would take 2 to the first to the fourth. So 2 to the 1 times 4, which is 4. And then x has a power of 1 also. So 1 times 4 is 4 for that as well. So each of those ends up with that x, or to that fourth power. So I'm going to write this out in a slightly different way for you. We took 2x times itself 4 times. And remember, from our 7.2 lesson, you take care of the numbers separately from the exponent. So 2 times 2 times 2 times 2, that's our 2 to the fourth. And x times x times x times x, that's our x to the fourth. And then if we want, we can go ahead and simplify that 2 to the fourth to be 16 and make that a 16x to the fourth. So remember, even the numbers, those have their own exponent and they're going to be dealt with on in its own way. If we look at our next example, we've got 2c to the third to the fifth power. And the 2 has a power of 1, and we would take 2 to the first power to the fifth power, so we multiply our 1 times our 5 and get 5. C is our base for 3, a power of 3 to a power of 5. Multiply, we get a power of 15. We could take our 2 to the fifth power and say 32c to the 15th. In our next one, we want to deal with these separately. Start with this first piece. 2 has a power of 1. 2 to the first to the third. 1 times 3 is 3. X to the third to the third. 3 times 3 is 9. That's our first part. Our second part we're going to deal with separately. So 3 has a power of 1 to a power of 2. So 3 to the 1 times 2, which is 2. And then x to the 4 times 2, which is 8. And we're going to take both of those and combine them together. So 2 to the third is 8. 3 squared is 9. And I'm doing that first to get the numbers out front. And then x to the 9th times x to the 8th. If we remember our 7.2 lesson, we've got 2 exponents with the same base. We add our exponents, so x to the 17th. Altogether, 9 times 8 is 72, x to the 17th power. In our next example, we're taking our -3, which has a power of 1, -3 to the 1 times -2, which is -2. Got x to the -4, because it's 2 times the -2. And when we work with negative exponents, our negative exponent rule said that we're going to move that to the opposite side of our fraction bar. So we've got 1 over 3 squared, because as we move it down, the exponent's now positive. X to the 4th. Move down, so the exponent's positive. And then 3 squared is 9, so that's 1 over 9x to the 4th power. In our next example, there are 4 different terms. There's the 2, which has a power of 1. We have an a to the 4th, a b, and a c squared, and all of that's taken to the 5th power. So each one of those 4 pieces is going to get that 5th power. 2 to the 1 times 5 is 2 to the 5th. A to the 4 times 5 is a to the 20th. B, which has a power of 1, b to the 1 times 5 is b to the 5th. And c to the 2 times 5, which is 10. And if we want, we can simplify that 2 to the 5th to be 32. And we've got a to the 20, b to the 5th, c to the 10th. We cannot add the exponents on the a, b, and c because they are different bases. Our last problem, we've got a negative in front of our parentheses. We're going to leave that negative alone for right now. And we're going to deal with what's inside. So our power to a power, we've got 2 to the 1 to the 2nd power, so 1 times 2 is 2. And c to the power of 3 to the power of 2. 3 times 2 is 6. Now we're going to simplify. We get -1 times 2 squared is 4 times c to the 6th is a -4c to the 6th power. Remember, with your power to a power rule, if you're taking a power to a power, you multiply your exponents. But don't forget, as you do your homework, the 7.3 practice worksheet, that you want to also keep in mind anything to the 0 power is 1, and negative exponents indicate that you're going to move to the opposite side of the fraction bar. And your product rule says that if you are multiplying 2 exponents with the same base, you add your exponents. Please practice using worksheet 7.3. Thank you.